I think we can learn from the steps which are made in the last 40 years. And Hendrik already mentioned that in the turn of the century, or on the century, there was really a big step forward. And I put it here in these cartoons. So we have this pancreas with kind of beta cells in the whole pancreas. We have the genetics and the metabolism, the genetics, and we have the localization diagnostics. And for me, it starts exactly almost 40 years ago. And here is a conference which we have together with some of the heroes. And you see, oh, sorry. You can see here Sir Ansley Green. He is still at many conferences, and you probably know him. But one of the other heroes is Claire Fekete. She was a surgeon in Paris at Hôpital Necker, and I think she was one of the persons who moved into the direction of focal disease surgery. And then there are, this is my colleague from a metabolic person, Böhles, and Wolfgang Grabe. I learned a lot from him. He was also a clinician with a heart, I would say, from Munich. And probably you have seen me in the background behind Sir Ansley Green. Yeah, so I want to talk today about pioneering discoveries, then the current treatment options and the gaps. And I call it Together We Are Strong, but I think already it was mentioned that this is our solution to get forward really in this very heterogeneous disease. I think these pioneering discoveries, I started with the first treatment. It was developed in 1964 by an observation, which was, we would today say it's only an observation, but this observation now helps a lot of you. It was something observed as a side effect in antihypertensive treatment, but now it helps about 80% of our group, of our children. And then the next big step forward is from the Philadelphia group. Charles Stanley, most of you know him very good. He first described the differentiation of the heterogeneous clinical picture of congenital hyperinsulinism. So he explained us there are two things. One is the hypoketotic hypoglycemia, and one is the glucagon response. And I think this is something which we now still have in our guidelines as the main points to go forward when we diagnose and treat these heterogeneous diseases. And I think everybody of you as parents, you were not aware that behind the scene there is a big discussion. What is the lowest level? If it's 3.9, if it's 3.5, somebody says 2.6, whatever. And you see the academics are not very smart because they have a lot of problems really to define what is really the safe value. And we are really not on the on the point that we can really tell you this is the safest value. But I think an important lesson comes from this work from Charles Stanley about ketosis. And the ketotic bodies are really necessary in this whole diagnostic procedure. And then Jacques Rayet, Actually, he came from Brussels, but it was a histologist who worked very closely with Claire Fekete, and she said, he is my pathologist. And every surgery she made, Jacques Rayet traveled to Paris from Brussels to make these surgeries. And so this was a very good start for a multidisciplinary team. And the next one was François Brunel. And I was really impressed when I sent a child, and I go with this child and the mother to Paris, to Necker, to see how he managed these diagnostics. And I will show you in a minute. This was a diagnostic with, he has, I would mirror hands, or like a, it was very impressive, I would say. Yeah, and then there was the time of the genetics. No, first there was the time Paul Thornton and Ben Glaser, they developed the somatostatin treatment, and they invented this treatment. Paul from Philadelphia at this time and Ben from Israel, they both have experience in this children with somatostatin treatment. And then the same group in Israel, Ben Glaser, and another group from Canada, they detected the most important genetic cause at the sulfonylurea receptor. And then at this time, the group here from, at this time from Manchester and it was in UK. Sir Ansley Green was formerly in London, later in London, but he worked together with Mark Dunn. And Mark Dunn, I think he passed away a few years ago, but he was also one of our heroes because he described the malfunction of this receptor. And I think this is a big important step forward. And then the group from Finland, Timo Otankoski, together with the Paris group, with Claire Fekete, and there were Heike Min, another one, they all together developed the DOPA-PET nuclear medicine. And so Madame Fekete, we always tell her Madame Fekete, she travels to Finland to make the surgery, and also Jacques Rayet travels to Finland. And this was really a big step forward for about 1/3 of the most severe cases with congenital hyperinsulinism. So this is really a history which I say these are pioneering research work. But still, the treatment of choice is also in very, very experienced centers, subtotal pancreatectomy for some of these children. And you see, even in the centers of excellence, Paul Thornton made a survey and he says, okay, here 25% were getting a pancreatectomy. In one center, no pancreatectomy. In one center, there were the reverse from the other center. So still, we have the problem unsolved in a lot of these children. And even with this subtotal pancreatectomy, we have this problem that you as a parents who had this subtotal pancreatectomy experienced, they know that there is not a clear solution of the problem. There are still these hypoglycemia. So you can see here, this from after surgery until about age 6, they have a lot of these scenes, sometimes longer, and then at least during the puberty, almost all of these children getting diabetes. But on the other hand, if we look for the psychometric investigations, this is a big step forward to avoid brain damage. So, as you see from the other slide, that it's still a treatment which we need, and I can't tell you how long it will be, but we now, I think one thing I have to mention, all children with limited surgery for focal hyperinsulinism, they never got diabetes. So the focal type surgery, if they are made in a center of excellence, then like as you see, if there's a good histologist, if there's a good pediatric surgeon, and all these team together, then these children are solved. And you see the situation, and I think the other Klaus will tell you more about this. When we developed in our center in Magdeburg a good connection with our genetist, and you see in our group of about 320 children where we get samples until 23, you see most of them have these ABCC8 and KCNJ11 mutation, then some with GLUT and some with other mutations, but still here is a big group which we cannot solve. In this group also some syndromic, like Wiedemann-Beckwith syndrome, like Costello or Kabuki, like Turner syndrome, whatever, some metabolopathies where we didn't really understand what is the reason for hyperinsulinism in this group, but we can see what is possible. In the focal type, I think this is also very, very interesting how it happens, and I hope Klaus will not bother me. I sent you this cartoon. We all have two genes in this region, KCN11 and ABCC8, from the mother and from the father. And if the loss of this normal allele and combined with the second time, and you see here even also Ben Glaser is cited because he developed this number, what is the possibility and the incidence, yeah. And you see when you have on the second paternal allele a growth stimulating gene, or you have on the maternal allele the growth suppressing gene lost, then you get this situation that you can see here. Here is a small affected cell, but this cell needs a second part. So everybody in this room, no, not in this room, but in different rooms, may have such mutation, but it will never occur as congenital hyperinsulinism. There must be the second hit, one of these, the loss of the suppressing gene or the increase of these paternal gene. Then we will have, you can see here, these bigger amount of insulin cells, and these are creating the problem. And I told you that François Brunet from Hôpital Necker investigated one of my patients, and you can see, I think in front, you can see, oh, sorry. You can see at this time in 1998, they have these very, very creative investigation. So the François Brunel, when I watched him, it was like an art, I would say. He has a catheter, and with the catheter, he went through the liver, through these veins of the pancreas. You can see all these are veins of the pancreas, and they go into the splenic vein. And then you can see here, the blood sugar was 44, 38, so low blood sugar. And the insulin values were 10, 8, 9, whatever. And in this place, I put here such a cartoon. It was 86. And there was 8 or 10. And you can see here, it's 195, it's 229. So it's really a very tiny place where they got the blood sample with high insulin levels. And you can understand that this is a very sophisticated method, but not only sophisticated, it was an art. And I know that, I remember that the mother was outside, sitting and waiting for the investigation, and I was in the room, and François Brunel, cries and say, "Oh, now!" And always he found, you can see here, when he comes into one of these veins, he didn't need any X-ray control. He says, "I have to do it because Madame Fekete will not believe me. But I know I'm here, or I know I'm here." So there was, at this time, there was no really good ultrasound. So he didn't trust on the ultrasound. He only had it in his fingers, and he saw, I'm on the right place. And 2 days later, when he gets the insulin levels, it was confirmed. Okay. And then 5 years later, I told you about Timo Otto-von-Guericke and the Paris group, and the Finnish group. They gave us the possibility with this DOPA PET, and we also, together with my brother, we did this combined with MRI, so we can see some techniques here. This is a very sensitive pancreatic duct, which has to be avoided by the surgeon. And some of these techniques are developed more and more. So we have a very low radiation, and so from this, I think from the Finnish group, we learned a lot how to deal with these localization techniques. And here are the next steps, the therapeutic goals. And I think these are the main points, and DIVA and in this group, we all together gave these international guidelines and say, okay, these 3 points: normal psychometric development with age-appropriate nutrition, fasting tolerance over 6 hours, and an organ-preserving strategy. These are our goals. And and this only can be get by close connections with the patients, with the families, and with the multidisciplinary team. But I think I have to really stress the patients, because we are only for 10 minutes, half an hour, 1 hour a year, and you are 365 days with this problem. And maybe you are not a specialist, but after a while, I think you are a specialist. You can trust me. When I talk to fathers and mothers, they will explain me much more, which I didn't know before. But I will not tell you that I didn't know it. Okay, these are the steps, and I think one important thing is as already mentioned by Julie in 2005, the foundation, and then the development of new therapeutic possibilities, stabilized glucagon by Zealand, then the allosteric inhibitory antibody. This is also a story which is, for me, very impressive because it was developed for diabetes, and then they find that there are other other antibodies in this part. But I think you can ask Resolute about these stories I didn't follow. But then I think one important thing is the genetic testing for free, because we all in a civilized situation world, we have to see that we are 8 billion people, and not only whatever some 100 million, and everybody should get this access. And I think this is really a good chance that people from poor countries can have at least in a bit of these new techniques. And I think the group from Sarah Flanagan, I think, made a good job with this. And then the global registry, you will heard here in a lot of this, and the collaborative research networks and centers of excellence program. So I think there are more to do. And I think the future research, I only put this because we all know and are aware that we need a newborn screening by biomarkers. We need glucose monitoring, which is better than only make a bloody test. We need other drug designs, and you already have this example of repurposing with the diazoxide. This is a classic example for repurposing. So a drug is developed, we know about the side effects, and we know that it's safe. And then we need these real-world studies, and I think clinical trials and the connection with industry, I think we cannot do anything without the industry and with the engagement of these groups. And I'm really happy that in this room are not only families and doctors, a lot of industry, and I cross the finger that you will get licensed drugs so we can have more in this direction. And here I only give this small example that we need here more for the global registry. You see mostly from America and Europe, but I think it will improve because the language problem is now improved. Here are the new drugs, like I only put here the glucagon, the allosteric insulin receptor antibody, and also there are some others like the selective somatosine analogs, which might have some important places. And for glucagon, I only want to tell you, glucagon is a drug which is known for more than 100 years. So we know that glucagon has his side effects, but we know these side effects much better than from other drugs. And I think this is an advantage. And you see here how it acts. It acts not only on glycogen, but it also acts on gluconeogenesis, but it also acts by mechanism, and it increases the insulin secretion. So there is a lot to study, and the problem with the commercial glucagon is now almost solved. We have now these new drugs like the dasiglucagon and the HANMI product. And I think this is something which is really giving more possibilities, more options for treating these children. And the treatment with somatostatin analogs, I told you that already in 1989 we have the first experience. Maybe there is some other news when we have these new somatostatin analogs. And then we have these research by Mark Dunn about the somatostatin receptors. You see when you look for the somatostatin, it normally acts on somatostatin 2 and it acts on somatostatin 5 receptor. And if you have the possibility to develop a more precise mechanism, then the side effects will be lowered. So this is one thing which we can obtain in the future. And then the monoclonal antibody therapy, I would say the Resolute company will tell you more about this. I only put here this cartoon. And this is something which is also very exciting, but has also still his side effects, which we can talk about during the sessions. And I think this is my last slide. And I see we have to develop in the future not only the new drugs, new options, but also our friendship. Thank you.